The topic lost and found comes from an unpublished book that I am working on, and the theme for tonight is stranger than fiction, which is a quote that maybe some of you know about. So the question is, who is responsible for this? 'Tis strange but true, for truth is always strange. Stranger than fiction, if it could be told, how much would novels gain by the exchange? How differently the world would men behold. Who wrote this?
Shakespeare?
Shakespeare is a good guess. Anyone? Not Einstein, was Lord Byron in an epic poem called Don Juan, which he pronounced Don Juan because he was an arrogant Englishman who didn't care about pronunciation. So we live in a very strange universe, and two of the chapters of my book deal with very strange oddities. Phil Plait is famous for bad astronomy, and I love his quote, "The universe is cool enough without making up crap about it." Truth is stranger than fiction. So in my unpublished book, I'm going to tonight to talk about two chapters called Lost and Found, but there are other space mysteries from history that have been solved through science. In my book, we solve them interactively, you and I together, by using 3D models, virtual reality, animation that you can play backward and forward. Tonight, it's just two chapters, Lost and Found, but I'm going to reverse the order tonight and start with Something Found. We start with asteroids who take very strange looping paths like this around the solar system. Sun in the middle, this is not to scale. Some of you know what L2 is, a Lagrangian point, stable places where the gravity of Earth and Sun balance, so we can put things there that don't drift away too fast. Anybody remember what famous thing is 1,000,000 miles away at L2? Went up recently. JWST, James Webb Space Telescope. A great place to put another telescope would be L1, so we could see what's coming at us from the sun, which blinds us. Because the chance of us getting hit by a disastrous asteroid that could wipe out a city or a country is about the same as one of us getting into a bad accident in an airplane over the course of a lifetime. It's not zero. So these looping paths, scientists come up with very clever names. They have all kinds of names for different orbits of asteroids. I'm going to go through this part very quickly to get to the weird asteroid, which is the topic of my chapter. But here's the different kinds of orbits depending on where they are compared to Earth, which is the thick dark line. Some are outside, some are inside, some cross from the inside, some cross from the outside, and they all have different meanings. The weird ones that take this kind of shape orbit, you'll never guess. Go ahead. Guess what astronomers call it? Horseshoe orbit. See the shape? So these things resonate between the gravity of Earth and Sun. It's kind of a tug of war. There are many different kinds of recurring asteroids that come near the Earth. And I want to eliminate all but the weirdest one, which is the topic of my book. Trojan asteroids, horseshoe vibrators, quasi-satellites, and more. There are two Trojan asteroids that circle around L4, 60 degrees away from the Earth in the orbit around the Sun. There are 13 horseshoe vibrators that go around both L4 and L5. Some of you may have heard the National Space Society was once called the L5 Society, and they wanted to build a space city at L5, a giant rotating tube that would give us what? Artificial gravity. Right? If you spin something, you're creating a false force, a centripetal acceleration that would feel like gravity. That's where they wanted to put it. The L5 Society is now called the National Space Society. Quasi-satellites, more elliptical than the Earth. There are some interesting examples here. Astronomers like to measure things in standard yardsticks. So the distance from Earth to Sun, 93 million miles, is an AU. But for closer things, we want to use the moon, minimum orbit insertion distance, sometimes translated to LD, lunar distance. 12 times the distance of the moon, no danger of collision. The moon's 250,000 miles away, so 1/4 of 12 is, mathematicians in the audience? Right, million miles. I had a friend who was irritated that somebody always asked someone to do the math when it was just simple arithmetic. Sorry, Eric. 20 asteroids on compound orbits. Look at the weird shape that these things take in relation to the Earth-Moon system. Moon in yellow, orbit of the moon, about 30 Earth diameters away. Look at this thing. Recurring near-Earth asteroids, 5 or 6 temporary. These are small, about 1 meter, which is 3 feet. It's like a yard, but bigger. If you like metric, I use both metric and English systems. So Earth has 1 or 2 of these things at any time moving around us. And then the Arjuna asteroids, very cool, very Earth-like orbits named after a hero in the Mahabharata. But what's the weirdest? The weirdest asteroid of all that is in my book is it this one? Nah, it turned out to be a Saturn V rocket, leftover 3rd stage. Did we go to the moon? Yes, we did. Don't let anybody fool you. WT1190F debris that burned up in our atmosphere years ago. This one is the Snoopy module from Apollo 10. Yeah, so we figured out what that is, 2018-82. You can see these are easy to remember names. Everybody repeat after me, 6QB. Never mind. And this is what 6QB44E looks like, artificial object. So these take very weird orbits in relation to Earth and Moon, and sometimes they just leave entirely. How about this one? Remember the Tesla Roadster, which ranges from little less than an AU to more than about 1 2/3 astronomical units, millions of kilometers or miles from us and the sun. 1.5 years to go around. No, the one I'm talking about was discovered by PAN-STARRS, Panoramic Survey Telescope and Rapid Response System. That's why astronomers abbreviate everything. It's just too hard to remember the names. This is at the Haleakala Observatory in Maui. Big mirror, almost 6 feet across, dedicated to finding NEOs, near Earth objects, sometimes called near Earth asteroids. Those can be dangerous, right? A large one colliding with us could wipe out an entire city. In September of 2020, 6 years ago, not quite 6 years ago, we found this, doing something very strange, looping around us, a temporary mini moon, a mini moon of Earth. But it left after some months in the next year to go around the sun. In relation to the Earth-Moon system, that's what the orbit looked like. But in relation to the sun, it had its own independent orbit. Everything depends on where you look at it from. That's what Albert Einstein taught us. There is no preferred frame of reference. I'm not the absolute center of everything. The Earth used to be the center of the universe. We know it's not. It's one of the planets orbiting an average star, which is among 1 trillion stars orbiting the Milky Way. Notice how the pink orbit catches up with Earth and crosses over. All right, so it comes close to Earth every so often. In the previous slide, we saw that compared to the moon, it does a weird loop. Compared to the sun, it doesn't. It all depends on how you look at these things. Well, we have to go back and look at what happened in 1966, a long time ago. Many of us in the room weren't born then. I was a wee lad. Actually, I'm way older than that. I go back to the Cretaceous period when there were dinosaurs. My wife will tell you. Thanks. This was launched in September 20th of 1966, and it crashed. It was supposed to land softly on the moon. It was a series of Surveyor space probes. Well, it took some teamwork between different people and different instruments to find out what this thing really was. One of the weirdest asteroids ever. Pan-STARRS, the Large Binocular Telescope, the Infrared Telescope Facility, and Vishnu Reddy, who was professor at the Lunar and Planetary Lab in Arizona. We knew from the Large Binocular Telescope that this was not an asteroid from the color of the thing, from studies. It wasn't a natural object. Spectroscopy, breaking up the light, you can tell what something is made of by breaking up its light into a spectrum, the way a prism does, breaking up visible light into red, yellow, blue, etc. There are other invisible wavelengths too. So when they did this, they found that it was hard to tell what was going on because the thing was moving so fast. Things move at 20 kilometers per second out in space, asteroids, per second. That's enough to cross the United States in minutes. Reddy's team had a suspicion that maybe this thing was an artificial satellite. They compared the spectrum of 2020 SO, the asteroid 2020 SO, and stainless steel, and thought, could this be the missing rocket from 1966, missing for 54 years? Well, there was a way to do this. They looked at a communication satellite that was in orbit around the Earth at the point where the satellite keeps up with the Earth's rotation, geostationary orbit. When you put a satellite there, from the ground, it looks like the satellite stays still in the sky. We use that for communication. We use that for when we set up our dishes to point at a geostationary satellite. So this thing was going around from 1971, an old stainless steel satellite, so they could get a good spectrum finally, and they compared that with 2020 SO, and what did they find? Perfect match. They identified 2020 SO was not an asteroid, it was the missing rocket, Centaur D, which looked like this. From this and other pictures, I spent a few months to build a 3D model of 2020 SO, or the asteroid. As part of the book, you can play with 3D models to understand what things look like. So to construct all these pieces took several months. You can move this in 3D, you can zoom in for detail, you can rotate it. You can do the same with 3D models of planets. We're not going to be able to see the trip. Oh, yeah. Oh, I could not start. I have a 3D animation of the trip from the Earth to the moon and the crash landing on the moon. That's part of the book as well, sped up 5,000 times. So the asteroid 2020 SO is the upper stage of a rocket. It will come back again, and its orbit has been changed by the gravity of Earth. The same thing is going to happen to asteroid Apophis in the year 2029 on April 13th. It'll be coming within the orbit of our geosynchronous satellites. Extraordinarily close. This thing is about 1,200 feet across. It will not hit us.
2028, right?
2029. I expect a lot of us will still be around then. So what happened to 2020 SO after we found it? Well, Brandon Spector in 2021 gave it a great goodbye in his article. He said, Godspeed, Mini Moon 2020 SO. We built you, we abandoned you. And now you abandon us. And off it went to orbit the sun. Is it going to come back? Yes, but it'll be more than 1 million kilometers away, almost 1 million miles from us. So no worries, we'll see it again. Now I want to talk about something lost, and maybe one of you can find it. In 1957, the first artificial object to be launched by human beings went to space. It was the Russian satellite Sputnik 1, and it created a firestorm in the United States. We were behind. We felt the pressure to educate our youth to become interested in science. And so They built, or a company called Remco built a bunch of scientific toys. This one is called an orrery, and I still have it. It influenced this young person to become interested in astronomy and science. If you go to see Area 51, anybody ever hear of Area 51? Yeah, in Arizona, at the Nevada test site, you will not be allowed onto the Nevada test site. You will be strictly watched. But you can visit the Area 51 gift shop. In 1957, the Nevada test site was a site of nuclear weapons tests underground. The craters are still visible today. There were many tests, about 29 explosions. They were trying to see what would happen with the effects of radiation underground, if this could be ameliorated, if they could reduce the effects of radiation. Unfortunately, they tested it on people as well as structures. And it was one of the largest US troop maneuvers ever. They even had balloon tests. Just before Sputnik was launched, October of 1957, there were two interesting tests called Pascal A and Pascal B. And those are the topics of my book. Pascal A and B were dug in a giant tunnel, 150 meters deep. That's about almost 500 feet. Long tunnel, 4 feet wide, at the bottom of which was placed a small nuclear device, a few pounds. They expected the explosion to be a few pounds. Well, they were surprised. Sometimes they got more than that, 55 in this case. And something went a little bit haywire with Pascal A. They put the bomb at the bottom and set it off. There was no cap on the top, and created what the test director, Robert Campbell, called the biggest Roman candle he ever saw. It was beautiful. If you know what a Roman candle is, this was a lot more powerful. Blue light, finest Roman candle, according to Robert Brownlee, the division leader of the test division. World's finest Roman candle was visible at night. Blue fire shot hundreds of feet in the air. Why'd they do it this way? Because they ran out of time. They were supposed to set it up during the day, go back to base, get some rest, Mercury base, get some rest, come back in the morning and shoot it off. But somebody said, we're here, let's do it now. And since it was at night, it looked great. Not like this picture, which is just a Roman candle. Pascal B was even more bizarre. And that's what's in my book. Pascal B similarly was at the bottom of the hole, but instead of putting the concrete plug that held measuring instruments near the top, they put it way down by the explosion at the bottom. That made all the difference. And on top of that, they welded an iron cap 4 inches thick, 4 feet wide to the top, a manhole cover. If you look it up on YouTube, look up manhole cover in space. When they shot this thing off, something else happened. And you can see that if you go to YouTube and look up manhole cover in space. One of them is in a YouTube series called Half as Interesting. And I think that one is very well done. There's the concrete plug down at the bottom. There's the iron cap at top. What did Robert Brownlee warn them when they put the cap on? It's not going to work. Was he right? Yep, it didn't work. It didn't hold it back. Now, this may not work. Let me see if it does. This is what they expected to see. Whoops, and it's off on another. Yeah, in fact, here's, I want to do this without losing what we have. Let's see, that's not working. All right, I'll play it later. They expected the thing to blow off. They had a camera outside at the opening to the tunnel. And they expected, because they were using, at the time, believe it or not, they could film. Oh, there it is. Now it's trying to come in. They expected to film it at 1 million frames per second. Movies at the time, 24 frames per second. This is 1 million frames per second. They expected to see the cap coming off. And what did they actually see? They caught it in one frame. One frame. There's a great, really funny conversation between Bill Ogle, the deputy division leader, and Robert Brownlee. And Ogle kept asking him, all right, what happens at the top of the pipe when the shock wave gets there? Well, Brownlee says, it doesn't really matter. Pressure, temperature, such. Well, the cap is bound to come off. How fast is it? Says Ogle. Well, calculations are irrelevant, blah, blah, blah. How fast did it go? How fast is it going? Ogle was getting a little frustrated. So by the time he asked for the fourth or fifth time, he yelled, how fast is it going? Robert Brownlee said, 6 times the escape velocity from the Earth, very calmly, 6 times what you need to escape the Earth's gravity. Think about that. You can see all this. I put the sites down if anybody is recording this or taking pictures or taking notes. And of course, I see nobody doing that. But that's okay. There'll be no test afterwards. So this should not have worked at all. For a 300-ton explosion with the tiny amount of radioactive material at the bottom, that would have all dissipated by the time it went 500 feet to the top. There's no way that that cap should have blown off, except for one thing. The concrete plug very close to the bottom vaporized. And that is what created the pressure that blew the cap off. And there are calculations to show this. You won't be required to remember this before you leave, don't worry. 5 times the Earth's escape velocity, according to the guy who has the website, Carrie Sublet, but that's still very close to the original estimate from Brownlee. 56 kilometers per second. That's 5 times the Earth's escape velocity, 11.2. That's really quick. Today, if you look at Google Earth, you can see where Pascal B was. And some of these explosion holes are still there. So the question is, and this is part of my space history mysteries, what happened to the iron cap? Well, for an answer, we can look to astronomy. And that's why all of you are here, to learn about astronomy from dedicated amateur astronomers who come here year after year just to help us and you. So if we look at meteoroids coming in through the Earth's atmosphere, space debris from old comets between 11 kilometers a second and 72, 160,000 miles an hour. Is that fast? Yeah, hypersonic technology vehicle 2 that's under development by the military reaches Mach 20. Mach 20 is about 15,000 miles an hour. That's nowhere near meteoroid speeds. Typical Leonid, which is what this is a picture of, a Leonid, which seems to come from the constellation Leo in that direction, 43 to 44 kilometers a second. So these things are very fast. What happens when they hit the atmosphere that fast? 5 miles of very thick atmosphere, the troposphere, what happens? Right. Usually these things are the size of a grain of sand. Right? Bigger ones, the size of my fist, might make it to the ground. But they generally burn up because of friction with the Earth's atmosphere. But we can calculate how much energy it would take to melt an iron cap that weighed 1 ton, or about 900 kilograms. And I asked an AI called Liner to give me the actual scientific research to do that. And it calculated that a mass of 1 ton of iron has a certain kinetic energy, over 1 trillion joules of energy. To vaporize iron, you need about 1 million joules per kilogram. We know the iron cap weighed 1 ton, or about 900 kilograms, so multiply 900 times that, and you could burn up 11,000 kilograms, not 900, 11,000. So what happened to the iron cap? It vaporized. It was vaporized? Or was it? Someday, some of you will be driving along the route from Las Vegas up towards the Nevada test site. And you'll come to the little red mark, the Area 51 gift shop. And you'll get a warning if you try to go much further into the Nevada test site. A group of amateur myth investigators and science investigators did this recently. There was a special on Nova about this. When they got to the sign, they were met with a drone, an aircraft, a Range Rover, cameras, and a few other things, watching them very carefully. So they went a few miles away on the top of the mountain so they could spy on the new area built on Area 51. And they were met with an aircraft, drones. But you could go to Area 51 with your metal detector. Will you find something? I'm going to leave you with a quote. I left you with a quote earlier that reality, astronomy, space is cool enough without us having to make up crap about it. Henry David Thoreau said, "Not until we are lost do we begin to understand ourselves." And another famous person you may be more familiar with, George Carlin, comedian, once said, "If I ever lose my mind, I hope some honest person will find it and take it to Lost and Found." Thank you. Before I stop, the National Space Society is looking for members. We have a New Jersey chapter, but I'm trying to get it reorganized. And I hope that some of you will consider joining the NSS. You can actually go for the least expensive version. And I'm going to try to set up the website for the New Jersey chapter so it's easier to find than it is now. So consider finding nss.org, where we're going to investigate the idea of putting a space telescope to look from L1 towards the sun, where there are objects coming that could harm us that we don't see because the sun's in the way. We need something dedicated there. That's one of the many projects NSS is dedicated to, including energy from solar power in space being to the Earth, and many other projects. Here's where you can find me, astronomyinmotion.com. Space History Mystery Solved is currently not published. I'm looking for representation, but when it is, we'll let you know. And there are 9 other mysteries to solve in that book. You've been a very good audience. Thank you for coming.